So two things: open policy agent and its policy language, and also introduce some Go language features. So here is a very typical Go program asking for permission. So let's say we want to buy a flat from the Housing Development Board. This, of course, is not the real Housing Development Board. Here's where the application asks for permission. And the decision is printed there. So the module checking for permission is the policy. So there's a lot of if then else logic there. Anyway, this is a completely valid Go program, and I'm going to run my presentation. So let's run the presentation. Yeah, not the real HDB, and of course, because I didn't write any code, there's no output. So the challenge with asking for permission is that complex if then else logic. This is the real Housing Development Board policy, just a little bit of it. For buying a flat in Singapore, you need to have at least one Singapore citizen, at least one other Singapore or permanent resident, and lots of other conditions. So the challenge now is writing that really complicated if then else statement. But before that, how do policy checking systems work? There's the input, there's the system, and there's the output. The input is typically in some sort of JSON or YAML or CSV file. And the system needs to convert that input into some internal data structure. And that's what I was talking about. This whole series of if then else statements to determine whether it is okay or not okay to proceed with a request. So at least one Singapore citizen, quite easy to scan, no problem. The if then else statement I can understand. How about this if then else statement? It gets a bit more complicated. Enter Open Policy Agent, or OPA. They created their own language to handle all these if then else statements. So a traditional if then else statement in a typical programming language would be if method is get and URL is not secret, okay. Or if method is post and the URL is new customer, also okay, return allow. Otherwise, return not allow. Rego if then else statement is a bit different, and it took me some time to understand, but they had good reasons to create a new language. The first line is pretty easy to understand. Default allow equals false. If you don't do anything, allow is false. Here is what is called a Rego rule. This is allow is a Rego rule, which returns true that blank defaults to true if there's nothing there, if method is get and URL is not secret. So there's an implicit and here, and there's an implicit true here. This space here is an implicit or allow is true if method is post and URL is new customer. So why did they do this? This makes it a lot easier to write rules, which we'll see later, from policy documents. I mean, real world policy documents like you find in a PDF file. Here is another example of an OPA rule. Not only can it return a Boolean, true or false, it can return a string, number, or JSON object, or array. So here, grant is an OPA rule, which returns this JSON object if income is less than 10. Or the OPA rule grant will return this JSON object if income is less than 5. Or the grant rule will return this JSON object if income is greater than 10, greater than or equal to 10. So how do we define our rules? Well, the rules have to live like Go, have to live in a package. And I've named this package Housing Development Board, HDB. Here's a rule, default, at least one citizen is false if I don't do anything. And the at least one citizen rule will apply true if input applicants underscore, we'll talk about that. But basically how you read this line is, if within the input you find some applicant where the applicant residence status is citizen, at least one citizen returns true. Now here is my data file. My data file is my HDB application.yaml. It has 3 entries. First is a PR, second is a citizen, and the third other. So let's run this. It's in an example directory. And I'll copy this command line and I'll talk about it after we run this thing. An example. And when we run that, it says at least one citizen is true. Yes, of course, we saw in the data, there was one citizen there. So explaining what we just did. So OPA assigns the YAML document you just saw to a global internal variable called input. And policy files like Rego files, data connections to external databases, these are assigned to an internal global variable named data. So when I typed in that command string, input this YAML file, data, this policy file, format just says pretty print the format. But here's the important part, data HDB. That is my query. What that query says is, please tell me everything you know about data HDB. Data HDB, there's a rule there. Please tell me everything you know about this rule. And in that case, the rule turned out to be true because there was at least one citizen. So, like I mentioned, all policies belong to a package, but there can be a hierarchy of packages. Let's say you want to collect keys for your new flat. You can have package hdb.newflat.keys. So, like I mentioned, that query data HDB means tell me about the policy decisions made in the HDB package. That was the output. So what's the meaning of this underscore in here? It basically, as I mentioned, it scans the input if there is at least some applicant where that applicant has a residence status of citizen. This rule is true. Pretty neat. I like it. But if that was all it could do, it's not very effective. Anyway, this just presents that the citizen goes through 1, 2, 3, found a citizen. Start. If that was all it could do, OPA wouldn't be a very powerful language. Here is where the real power comes in. This line, you now know. If you don't do anything, at least 2 citizens or a citizen and a PR, that rule is false. Here, I can say for some I and j, some index value I and some index value j, if I find applicant I to be a citizen and applicant j to be a citizen, implicit and here, and I is not equal to j, then this rule will be true. Or if I can find some applicant I who's a PR and some applicant j who's a citizen and I is not equal to j, then this is true. Now you see the power of the Rego language in OPA. You can write very, very complex policies with these kind of structures. And I'm just scratching the surface here. So like in any good programming practice, we need to test. So how do we test policy? Obviously, when you're dealing with people's lives, HDB flat and all that, you need to make sure that you make good policy decisions. So a test by convention is prefixed by the keyword test, but it's convention. It's not a keyword. It's just a convention. So this is exactly like a rule. This rule is a big rule. It starts from here and ends here, and it has 3 parts with implicit and between them. So it's exactly like a rule except with a with keyword, with input as. So I'm providing the input directly to the test in this JSON structure. So I'm providing this JSON structure directly to this test. So here I've got 2 applicants in the JSON structure. I've got 2 citizens, true. I've got a citizen and a PR, true. Other and a PR, false. But I prefix it with not. So not false is true. True and not false, the test will pass. So let's run this test. It's called 2 example. So OPA tests everything in this folder, give me verbose output. And basically it says pass. Yeah, because we had 2 citizens and a PR. No problem there. Let's change the test fixture to purposely cause a failure. And it says change the test fixture from, okay, so citizen to citizen other. Well, I think it's not quite right, but let's see. So at least 2 citizens and a PR. So let's change the PR to other here. So this will fail. Save. Rerun the test. And indeed, it fails. It tells you exactly where it failed. Cool. Nice. I like testing code. So how do you deploy OPA? Open Policy Chain, or OPA, can be deployed as a standalone binary because it's written in Go. And that's how I've been running OPA in this talk so far. You can deploy it in a sidecar container as in a Kubernetes pod, or in a standalone Docker container in some containerized environment. And here is the superpower. It can be a library linked into a Go program. Now, the usual way to interact with OPA is via HTTP JSON calls. You make calls to this OPA process, and OPA responds over the network to you. But if you link it to the library, you don't have to rely on the network. So self-contained policy checking with Go. That's part 2 of my talk. So, like I mentioned, furthermore, if you want to extend, create functions within OPA itself, you can write OPA functions in Go, obviously, because OPA is written in Go. And it can be integrated with a Go application and deployed as a single binary with no external dependencies. My favorite feature of Go. So here is the buy flat application again, but now a little bit more fleshed out. Here we now have real data structures where the application decision is approved, true or false. And here is my application to buy a flat. It has a PR and a citizen and one other. And here is the code. Now you will understand this code because it looks very familiar. First, we create a new Rego object called RG. And within the Rego object, we have package HDB. We have seen that before. Default at least 1 citizen. We're talking about 1 citizen only. False. Input applicants, if there's some applicant where the resident status is citizen, true. Here's where we evaluate the policy. If there's an error in Go, print it out, and we declare a variable called application decision and return whether it's approved or not. So let's run the code. I like running code. It's called perm2, go run main. Application result approved true. Let's make sure we trigger a non-approval here. So there must be at least one citizen. Change this to PR. Approve false. We need to have at least one citizen. So explain Go interface, empty interface, and type assertions. Let's look at the code now. OPA is written in Go, but policies can be anything. Some manager thinks up some policy, some politician thinks up some policy. They can write it down in a PDF file or wiki, and this policy can be anything in the world. And Go is strongly statically typed. How do you reconcile these two? Well, when you evaluate the policy, it returns a result set. And the result sets contains expressions and bindings. Expressions are these things, the rules, and bindings are variable bindings, which we didn't really talk about in this talk. But anyway, the first expression, index 0, look for expression 0, the first expression. It has a value. This value, because of the flexibility of OPA, can be anything. In order to make it type safe, I need to tell Go what I expect. What I expect there is a map of string to anything. This anything is called the empty interface. So because I made the value a map of string to something or anything, I can now specify the key, at least one citizen. So I'm pulling out this rule. And when I pull out that rule, that content of that rule will evaluate to true or false. But I said anything. So I need to typecast it or type assert it to a Boolean. Why Boolean? Because application decision, the approved field is a Boolean. So in this case, I have two type assertions, two of them. The first, map of string to anything, and the second, after evaluating its value, type assert it to a Boolean. So Go is really cool. You now have a type-safe application. Let's build a statically linked file. Thing which I was telling you about. Really cool. No external dependencies. So C Go enable Go build builds the perm2 file. File perm2 tells me it's an ELF64 Linux executable. Where is it, Linux? It didn't say, but statically linked. And the size is 15 megabytes. So for the price of a 15 megabyte binary, I've got the whole of the OPA policy engine in my binary. Really nice. But here's even better. That executable runs on Linux. This executable runs on Windows. And it's even slightly smaller. So with the same source code, I can create a Windows binary. How about Mac? Go to list. These are all the targets Go can target. AIX, Android, Darwin is Mac. I don't know what Dragonfly is. FreeBSD, WebAssembly, whole bunch of Linux flavors, NetBSD, OpenBSD, Plan 9, Solaris, and Windows. Very, very nice. So I like to tell people Go is Java done right. So as usual, the presentation and source code is available from my GitHub repository. And as a bonus, if you want to learn more about OPA, there's actually a second presentation in there, but I've made a video of that as well. So this is the time if you want to take a screen capture or write down that YouTube link, or later catch up on the video playback, you can visit the other presentation on how to write functions in OPA. So that's all for my talk. Thank you.